Flip is a technology to make real-time collaborative applications. So we'll first see why make real-time collaborative applications, and later, how does it technically work and why it can make you develop faster. Google Drive Spreadsheet is the best when it comes to sharing figures and team working because it allows real-time collaboration. But we also know it's limited by performance and lack of features compared to Microsoft Excel. With Flip, you can build a fully functional native application, but still be collaborative. In fact, it's all about workflow. In the sequential workflow, users have to exchange files one after the other. This breaks workflow. And the more numerous users there are, the more painful it is. Moreover, if they work at the same time, conflicts happen, and in some cases, work can be lost. With the parallel workflow, all users can edit the document at the same time. They don't have to wait for each other. Every user can modify the same document at the same time rather than waiting for their turn. It's more efficient because it can do just more than the sequential. So if your application is used by more than one person, ask yourself what it could become if they might work on the same thing at the same time with no errors and with no loss. Flip is a data model API. Basically, in a model view controller design, Flip manages your model. Therefore, Flip is something close to Apple's core data technology, except that it manages real-time collaboration, is cross-platform, and we believe it is easier to learn and to use. Let's study an OM Studio-like architecture. Here, a user application asks the server to join a document. The central server, on an AWS Ubuntu hosted by Amazon Web Services, instantiates a specific Flip server process that will handle this document. Every new client that connects to this document will download the current state. Every model modification leads to a transaction that is first applied locally immediately and then sent to the server. These transactions can be refused by the server when it detects a conflict or a possible corruption. Let's take, for example, a very simple application with a star and a square. Users can move them or make them unmovable. A conflict will happen, for example, if Peter makes the star unmovable, and almost at the same time, Stephen moves it. Unmovable transaction arrives first and is accepted by the server, whereas Stephen's move is refused. When unmovable transaction arrives to Stephen, Flip rolls back the move action as if it wasn't confirmed by the server yet and applies unmovable action. Then Flip tries to apply again the move action, but cancels it when it discovers it is now impossible. A bit later, server confirms that the move transaction is refused. Of course, this kind of conflict is rare and happens faster. But at the end, everything is kept in sync by Flip without lock mechanisms. Flip manages undo and redo operations. When you'll modify your document, you'll specify when you start and when you end it. Then Flip will create the corresponding transaction and send it to the server. Flip will play the transaction backward for an undo operation and forward for a redo operation. So as a developer, you won't have to create tons of action classes where you have to code a revert function for every action. This was time-consuming and used to generate lots of bugs. That's why we also use Flip for standalone applications. Here is a couple of examples. The memory and CPU footprint is as low as possible, so we develop faster, more reliably, and with greater performance. For standalone usage, the server is as if embedded in the application. Another key point is that during a real-time collaboration, Flip will treat users' action stacks independently. Here is an example with two users. They duplicate 4 times a pattern, then undo, then redo. We see that a user won't undo an operation done by another user, which would really mess things up. A small HTTP server is embedded in the sample code and shows you important data: memory and CPU usage, number of collections, number of transactions per minute, as well as logs and running session details. This tool helps you understand your application's usage and detect issues. That's also a good way to check good performance. We've been working with Flip since 2007. It has been used in production for 2 years, and during that period we encountered only 2 bugs due to Flip. We consider this technology mature and stable. So here is a summary of why using Flip is great. Making real-time collaboration application becomes possible and easy to do. No more synchronization issues. Your development will be easier as you won't have to manage undo and redo operations. The CPU and network usage is very low. It's designed to go in the cloud and take advantage of storage capability. We haven't encountered a single bug in Flip in more than a year. That's easy to develop with. You just code as if this is a single user app. So now, check our page to download the API and watch our documentation. It's under GPL 2.0 license, so you can test it and build open source applications with it for free. For any technical question, use the SourceForge forum. For any commercial question, contact us.